All right, here's a little extension to the tutorial I gave on Tuesday. So during the presentation, I got confused a bit by this slide and thought, oh, this slide is wrong. And then I was looking at the code and the actual policy, the resolution policy I'd implemented didn't work there either. And so that I found it a bit frustrating. And so I've fixed the issue. Well, so first of all, on one hand, this slide is not wrong. On the other hand, it is wrong. So what I want to do now is to explore exactly what is going on, both in the slides and in the code. So let's go back to look at what the problem here was originally. So to do that, I have to go back a couple of slides. So the issue here is we are studying resolution of module names, of imports. And let me actually go back to the original model here. So in modules, what we do is we declare a module name in the main scope, in the root scope. And then we add a parent edge from the module scope to the root scope, in order to allow lexical bindings, in order to allow bindings in the module to see bindings outside, right? For example, the C here should resolve to the C in the outer scope. And then if we look at imports, imports are names that are resolved in a scope. For example, the import of B over here is resolved in a scope. It goes through the parent edge, and then it finds a declaration in that main scope. And that is fine according to the policy which we've defined here, which says resolve imports names in the mod namespace through 0 or more P edges. Okay, so this import, so the name of the import resolves to this declaration, and the effect then in this policy here is to add an edge from the importing scope to the imported scope, right? The one that we obtain through the resolution of the import path. Okay, so that leads to adding that import edge, and subsequently we can resolve names in a module through that import edge and through the P edge we already had. Right, so for example here the C is resolved through the parent edge to the lexical scope and the lexical parent scope, and B is resolved through this import edge to the definition in module B. Okay, so another policy here is that now we can get situations like this where we have multiple resolutions that are reachable with the same name. Right? For example, here we have the situation that we have a declaration of B in the root scope, and we have declaration of B in the imported scope. And so this use of B in module A has two possible resolutions. We can resolve it through the parent edge to the outer scope, or through the import edge to the B scope. Okay, so now we need to resolve that, and we resolve that by means of a path specificity order. In this case, we choose to say import resolutions are preferred over parent resolution. So in this case, we would prefer the blue path over the red path. Okay. So now, so this works for mutual imports, mutually recursive imports, and transitive imports, etc. But now let's look at nested modules. So here we have the same resolution policy. And modules are declarations, so modules can occur nested within other modules. And so what we would like to do in a module is import the module and then import the modules nested in that module. right? So that's what we're doing here. So the idea here is we want to resolve little b here to the b in module a.b. And in order to do that, we first import a, and then we import b, which becomes reachable because we have imported a. And okay, so how does this work in our policy over here? We resolve a, the import name, in module C. We can resolve that through the parent edge in the global scope 0 to this declaration here. And that means we add an import edge from the importing scope 3 to the imported scope 1. And now next we want to resolve the import of B. Again, we resolve the name. When we look at the parent scope, there's no B over there, but there is a B following this import edge to this declaration over here. So we reach the module, the scope of, so we get the type of B over here, and its scope is 2. So we construct an import edge from scope 3 to scope 2 to represent that import, and subsequently we can resolve the variable B in this scope through this import edge over here. All right, everything's fine. This whole approach works for nested imports. At least that's what it seems. So now let's look at the variation of the scenario. So now I've renamed the nested module to be to also be named A, and well, that's not a problem in itself, right? I mean, but now let's see what happens to resolution. So we resolve A again in the global scope. We end up right through the parent edge. We end up in this declaration. We add an import edge, and now we can resolve the second A. Well, there's two possible ways, right? So we can resolve it through the parent edge or through the import edge. It is resolvable through to this declaration over here, and because we have this disambiguation rule that says that we prefer imports over parents, this A resolves to that A, and therefore we add this import edge. However, I mean, there's really not a difference between the two imports over here. I mean, this one was also just an import of A, and so actually the original resolution to the of this A to the outer A is no longer valid, right? If we would re-resolve A in this new situation, well, in the situation where we would have added the import edge, then like the resolution of this A should also resolve to that A. But the resolution of the original resolution of A to the outer A calls this import edge. So if we now resolve this A to the inner A, then, well, there's no justification for adding this import edge, and therefore we cannot actually resolve A. So this is the paradox we're in. So in statics, the requirement is that resolution answer should be stable. So when we do resolutions after we've constructed the whole scope graph, that those answers should be the same as we did them originally. So if we do a query that may result in later changing its own result, right? So here we have a resolution of A that then causes this I edge to be added, which actually causes the resolution of the same A to be changed. That is no longer valid. And so statics will get stuck on such queries. We are still looking at a way to detect whether specification can get stuck, but for now, at least they don't. Statics specifications are sound, so they never produce scope graphs that are inconsistent, where query results are not stable. And we can actually solve this problem by better encoding. And the better encoding is to say, well, we want really what we want to do this properly is to have an ordered, we need to scope imports. Namely, what we want to say is when we import a module A, then we want to create a new scope, and whatever we imported is then available to the rest of the module, but it's not available to itself. So we cannot influence, by importing a module, we cannot influence its own resolution. And we achieve that here by introducing, rather than having modules as just a bag of declarations, we introduce this notion of declaration groups, and declaration groups are separated by semicolons, and the declarations in one group are visible in the next group, but not the other way around. So this import A is not visible in this declaration group. And we model that in this graph as follows, right? So we resolve A in the outer scope through the P edge. We add an I edge, and then we resolve the next group in a new scope. And what we do here is we create a parent edge to that scope, and now we resolve A in this scope, and we can resolve that through the parent edge, through the I edge to this A edge. Well, but now you might say, well, we can still resolve this A import through this import scope, or this import edge, and so that is still problematic. But what we do here now is we slightly adapt the resolution policies for module names, requiring that import name should be resolved through at least one parent edge. So rather than saying, well, we can resolve through this import edge, we always first have to resolve to a parent edge, and then we're there. And so this works. So this slide actually works. This model actually works. We've resolved this edge, this import through this parent edge, and this one through this parent edge, and then through the import edge to the A scope over here. So I was a bit confused, but the thing is why this works is that we have changed the resolution policy. Still, this model isn't entirely right, and that's what I realized when I was looking at the code. So now let's switch to Eclipse and look at what this code looks like and how that can be fixed. All right, so we're back in Eclipse, and what we have here is the model I had originally implemented for members, and I've slightly changed the specification as compared to the slides. So let's quickly look at the syntax. So what we have here, a module has a bunch of members, and members is either a bunch of declarations, so 0 or more declarations, or it is a sequential composition of members, and that's these declaration groups. And so here in the spec we see, well, here we have a declaration group, and here we have a declaration group that are sequentially composed. Okay, so to specify that, what we do, so before in the model, the simple model was just check that all declarations are okay. Now we have a predicate that checks that the members of a module are okay, which is when it's just a group of declarations, then it's checking that the declarations are okay. But if it's such a sequential composition, then it's like a let-like construct. We check that the first group is okay in the scope, the given scope as 1. We create a new scope for the subsequent group, and we check that those members are okay in that scope, and we do construct this P edge from the next group of declarations to the previous group of declarations, so that declarations in that previous group are available in the next group, but not the other way around. Okay, so and when I was looking at the implementation during the tutorial, so this works fine in the scenario that I showed on the slides, right? So we have a nested module E over here that defines an F, and that now correctly resolves. And if I remove the declaration group here, so the edges are both in the same group, then this doesn't work anymore. And let me check, because now the two E declarations both go to the same module. Okay, so the resolution policy is slightly different than on the slide. So what I've done here is I've defined a query that says you can resolve a module through 0 or more P edges and then 0 or more I edges, right? To have this policy that you cannot resolve in the parent lexical parent after you go through an import. But in the on the slide I said, well, we need to adapt this policy to first go through a P edge always, and not directly go to an I edge. But I've modeled that here slightly differently by defining a scope of parents predicates that, well, gives the parents of the current scope. And then when I'm resolving an import, I first take the scope of the current. It should really be called the parent of the scope. So the parent of the current scope S, and then we start resolving in that scope. So that gives us the policy that we saw on the slide. So if I would instead resolve directly in a scope, we would get into this situation where queries get stuck, and that leads to a result like this. Okay, so we do want to resolve in the parent of the current scope. Let me just rename that. This is silly. Oh, I suppose scope of parent would work as well. Okay, but now you're right. And if I use this declaration group, then I correctly resolve through this parent edge. But now the problem is that if I have if I would add a module H, and I define an A in there, and here I would import a module H, and through so let's say through a, well, okay, let's first do this and then check that. Then this works fine, right? So we import E, and in E we import H, so we can we have transitive import, so that works fine. But if I would use a separate declaration group for H, then in order to resolve A, I go through the import edge from G to E. But actually I would end up in the bottom scope here, and now there's a parent edge going through module H. Well, there's a parent edge going to the import scope, to the scope in which this import is imported. This H module is imported, and then I have an I edge, and that doesn't quite work with the resolution policy for variables, right? Because I said, well, we shouldn't resolve after we do an import. We don't want to expose the lexical environment of that module to importing modules. So therefore we have this policy that we first resolve through a bunch of parent edges and then through a bunch of I edges. And the scope graph I've just created here is I edge, parent edge, I edge. So that doesn't quite work. And that's what I saw during the tutorial. Then I said, okay, so we need something else for the inner parents of a module. And so the idea I came up with is to introduce to label these edges differently using the M label. And then things should be fine. And so what I said here is, well, I can still do some M edges. And that was a bit too simplistic. So really what we want to do is we want to resolve, so now we get a chain of M edges. And so you want to resolve through a bunch of M edges, and then you can do more imports. So really we want to be able to alternate M edges and I edges. And furthermore, so that's for variables. Furthermore, for modules, we also want to resolve the imports through those M edges as well. Right? Before I said, well, you should at least go to one parent edge, but there might be a whole bunch of those, and those should be those become possibly M edges as well. So also for modules, we want to be able to let's see, go through M edges and through M edges here as well. And then if we look at parents at parent of scope, then the parent may also be an M edge. So now if we so now everything works fine, right? So the A variable here is resolved through the import that ends up in the in this scope. There's an M edge to this scope, and then there's an I edge to this scope, and then we're there. And even if we add more then this should work out fine. And we also get shadowing. Well, let's test that. So if we would make this a Boolean, right? If this is if we make this a Boolean, in this case we get a duplicate definition. But if we make this a declaration group, then this A shadows that A, and we get the right behavior. Right? And if we swap those, we see that we get an error here, because now it thinks that this thing, well, it sees that this thing is a Boolean. Okay, so that's it. Let me go back to the slides. Where is it? So here we are. So this slide indeed was wrong, but for another reason than I thought. And really what it should be is it should be something like this. We use a different edge for these internal module edges, and we need to adapt the resolution policy for modules and also for variables, as we saw, in order to be able to resolve through those M edges. And then we get a nice resolution policy to resolve these modules. All right, that was it. I hope you enjoyed the tutorial, and if you have any questions, then try out Spoofax. Let us know. Join us on the Spoofax users channel on our Slack organization, and send me an email if you want to get invited on that. Thank you.